Now that we covered viewChild and ContentChild, we can also explore some new lifecycle hooks that are worth mentioning. But now it's the after_view and after_content init lifecycle hooks I want to take a closer look at, before we then also explore after_next_render and after_render. Because these hooks can be useful if you are dealing with elements that have been selected with help of viewChild or ContentChild. And therefore, let's start with the after_view_init hook. To avoid typos, I'll again implement the after_view_init interface that is provided by Angular and that is imported from @AngularCore. Because this interface then forces me to implement the ng after_view_init method, like this. You can also omit this :void thing here though. That just tells TypeScript that this method doesn't need to return anything. But here I can then log after_view_init. And what's now the idea behind this hook? Well, in this hook here, you are guaranteed to have access to the elements that have been selected with viewChild. Unless you, of course, specified some selector that can't be found. But you are guaranteed that the template has been initialized and that in theory, Angular therefore is able to select elements in there. So here we can console log this form native element and we should get a result. On the other hand, if I also implement onInit, so this onInit interface, which is also imported from AngularCore, and I therefore add the ng onInit method, which you already saw before earlier, I'm not guaranteed that this element exists yet. So if I log onInit here, and I try to access the native element here, you'll see that if I actually go away from that signal form here, back to using that viewChild decorator, and therefore I'm not executing this, but instead I'm accessing the native element like this, and also like that down here. If I change that code and I save it all, you'll see that now if I reload, I got the onInit log here, this one, but then I see undefined for that value that I'm trying to get hold of with viewChild. Whereas in after_view_init, I do get hold of that element. That's the difference here. Now things are a little bit different if you're using the viewChild function. There you can actually also read it here inside of ng onInit, but when using that decorator, there is this important difference, which you should be aware of. Because that difference, of course, means that if you're using that decorator for selecting an element and storing it in a property, and you then want to do something with that element, you can only do so in after_view_init or any of your methods that are triggered from the template, but not inside of ng onInit, because there it would still be undefined. That's something to be aware of and something to keep in mind, and that's why this lifecycle hook exists. And that's also why we have this ng after_content init lifecycle hook. Because here in the control component, if I implement after_content init, which of course also is imported from @AngularCore, and I therefore then add the ng after_content init method here, I can safely access that content, assuming that I got a correct selector here, inside of ng after_content init, no matter if I'm using the ContentChild function or the ContentChild decorator. Just as with @viewChild, @ContentChild would not produce a value if I would try to access it inside of onInit. Inside of ng after_content init, on the other hand, I'm guaranteed to get hold of these values that are selected with the ContentChild selector, if I did specify a valid selector here, of course. So that's the idea behind ng after_content init and ng after_view_init. Now, two other interesting lifecycle hooks that are actually registered differently than the ng-on-init and all those other hooks are the after next render and after render hooks. These are also not available in older versions of Angular. They have been added with Angular 16. And you do register them with help of the constructor. So not as methods in the component class, but instead with help of the constructor. Because in that constructor, you can then call after render. So this after render function, which is imported from @Angular core. Or alternatively, after next render, which is also imported from @Angular core. And to both functions, you then pass a function as an argument. And here I'll console log after render, and I'll console log after next render. Now, what's the idea behind these lifecycle hooks here? Well, if you save that, and you go back and you reload, you see after render and after next render are executed here. But you'll also notice that after render then is executed again and again, basically whenever anything changes on that website. So not if something changes in this component, this control component, but anything anywhere on this website, anywhere in this Angular app. After render is logged over and over again whenever any change occurs, whereas after next render is not logged again. Because the idea behind these hooks here is that they allow you to define functions that should be executed whenever anything changes anywhere in the entire Angular application, or after the next change anywhere in the entire Angular application. So it's always the entire application we're talking about here, whereas the other lifecycle hooks, like ng-on-init and so on, refer to the component to which they belong. With after render and after next render, it's the entire application instead. But the difference then is that after render will execute a lot because it listens to all future changes, whereas after next render will only be triggered for the next change anywhere in the entire application. And therefore, if you have some code that should be executed whenever anything changes anywhere, or after the next change anywhere in your application, these two special hooks, these special functions, can be helpful. So you did now learn about more lifecycle hooks and about viewChild and ContentChild. Before we continue working on that new ticket component and we make sure that we actually use the submitted values to advance our application, there's one last kind of lifecycle related feature I also want to introduce you to. Though it's not technically a lifecycle hook, instead it's a signal feature. And to understand it, I'll go to the server status component. In there, in my application, I'm currently not using a signal, but I'll change that now. I'll change the current status property from being a regular property to being a signal by executing the signal function provided by Angular core. So I want to manage my state here with help of signals now. For that, I'll initialize this signal to the value offline. And therefore current status now will hold a signal as a value, and hence the type of current status is no longer one of these strings, but instead it's a writable signal. But I'll take advantage of the fact that I can overwrite the inferred type of the value wrapped by that signal by adding angle brackets here. And I'll tell TypeScript that the value managed by that signal is not any kind of string, which would be its inferred value, but instead that it's one of these three strings. Initially it's offline, but it could be online or unknown. So now current status is a signal. Therefore, if we want to update it, we have to do that with help of the set method. So in all those places where I change the signal value, that's now done with set. And in the template, we now have to read that. So we have to execute current status as a function. Like this. With that, if we save that all, this application still works the way it did before, but now I'm using a signal in the server status component. Now, why am I doing that though? Well, because sometimes you have code that should be executed whenever a signal value changes. Now, if you're using a signal in a template, like I'm doing it here in multiple places, Angular will automatically set up and manage a subscription for you. And it will automatically update the template whenever the signal value changes. But what if you want to listen to a change in your TypeScript component class? There, let's say in the constructor, if I read this signal value like this, Angular will not set up a subscription. Instead, if I read it like this and I reload here, you will see that offline gets logged here. That's coming from that server status component TypeScript file from the constructor there. But then we never see any other offline, online, or unknown log thereafter. We only have this one log. And the reason for that is that, as I just explained, Angular does not set up a subscription here. Which is good. That means you can safely read signal values in your TypeScript code without setting up accidental subscriptions. But the downside is that sometimes you might want to set up a subscription and you're not getting it then. That's why Angular offers you a special function, the effect function, which is of course imported from Angular core, which you can execute in your constructor, for example. And effect takes a function as an argument, and if you then use a signal in that function that's passed to effect, Angular will set up a subscription. So by moving this code into this function that's passed to effect, Angular now does set up a subscription. And it will automatically clean up that subscription if that component should ever get removed from the DOM. But with that, if I now save that and I reload, you'll see that now I got offline here, and we'll get new logs from time to time, like here with online, whenever the signal value changes. And that can be a useful feature, and therefore, whilst effect is not technically a lifecycle hook, it's a very important function you should at least know about, because it does allow you to run code when signal values change, which you might not need all the time, but which you might need sometimes. And that's therefore how you can use that effect function.